taking your limit, just take the limits of each one and then add or subtract. Same thing with multiplication and division, with the exception of when the bottom is 0, and you can never divide by 0. In essence, when you're trying to take a limit, just go ahead and plug that value in. If it works, great, that's your answer, you're done. If it doesn't work, then it requires a little bit more work. So, whenever possible, just try plugging in the number. So here's 3. Plug it in, 3 squared plus 2 times 3 plus 4, and we get our answer. Same idea on the one on the right. Just try plugging it in. 2 times 3 plus 5, 3 squared plus 2 plus 4. Plug it in, you get your answers. Well, you want to do that for all of them as your first step. So when we're looking at our limit as x approaches 1 here, when you plug in 1, of course you get 1 on the top because that's not going to change. Then you get 1 squared, which is 1 minus 1. So you get 1 over 0. Oh, we can't divide by 0, so we got to use a different approach. But you will realize that the bottom is differences of squares. So it's like, okay, what can we do here? Well, let's go ahead and try a number just to the right of 1. And so that's what I mean by this little plus sign as kind of like an exponent. That means, what happens if I try numbers slightly greater than 1? Well, if I try a number slightly greater than 1 and add 1, well, that's basically going to be 2. If I try something slightly greater than 1 and subtract 1, well, then that's a really small but yet positive number. Well, let's see. If I double a small positive number, it's still small positive. 1 over a small positive, well, 1 over a positive is positive, but 1 over a small is really, really big. So in other words, it's positive infinity is what it's diverging to when you try a number slightly to the right of 1. Well, you want to use that approach also coming in from the other side. What happens is I look at a number slightly to the left of 1, and that's what I mean by that little negative exponent. That means you want to try numbers slightly smaller than 1. Well, of course, the top's still going to be 1. You try a number slightly smaller than 1, and you plug it into your x plus 1, and well, it's basically 1 plus 1, so that's where we get the 2. Number slightly smaller than 1, like the 0.9999 stuff, minus 1 is just a negative, but just barely negative, so it's a small but negative number. Small meaning close to 0. So now you got to double a small negative. It's still going to be small negative. So positive 1 divided by small negative is going to be a negative answer. And 1 over a small is big, so it's a big negative number. So negative infinity. So are we approaching the same thing on each side? No, we're not. So therefore, there is no limit since the left-handed limit and the right-handed limit are different. So we're going to continue on here. We're going to try to go ahead and just use that direct substitution. Just plug in what we have. So we're going to plug in 2. You plug in 2 on the top, you get 4 minus 4 is 0. You plug in 2 on the bottom, you get 4 plus 2 minus 6, which is 0. You get 0 minus 0. That's an indeterminate form. We can't evaluate it when it's like that, so that means you got more work to do. So you'll notice the top is differences of squares. The bottom is a nice trinomial that factors. Well, you'll notice, oh, same factor top and bottom. So with the same factor top and bottom, you realize that they cross out. So you're really left only with your limit as x approaches 2 of an x plus 2 over an x plus 3. Now we're going to try that direct substitution. you want to go ahead and you want to plug in 2 for your x. Well, 2 on the top, 2 plus 2 is 4. 2 on the bottom, 2 plus 3 is 5. So you get 4/5. So whenever possible, do that direct substitution. If it doesn't work, that means you got a little bit more work to do. If it does work, that's great. You're done with the problem then when you plug it in. So looking at the next problem, we want to see, does it work to just plug in 4? 4 squared is 16. 16 plus 9, oh, that's just 25. Square root of 25, well, that's 5. So, hey, it works. Great, we're done. We move on to the next problem. Plug in our 4. Do a little bit of simplification here. Get 24 plus 40. Cube root of 64. And you should know that that's just 4, so that's your answer. Limits of trigonometric functions. Well, basically, you can go ahead and figure out your limits of any trig function just by plugging in the value, assuming you're not at a point where there's a vertical